Structured bindings, introduced in C++17, are a way of binding readable names to the values of arrays, tuple-likes, and structs. Its main value comes from accepting multiple return types from a function or adding more meaning to a pair or tuple. In this video, I'll show you how and why to use them, but also why you might want to avoid using them in certain scenarios. But first, let's talk about how to use them. To start out, we'll need some piece of data. We can use an array, tuple-like, or, since C++20, a struct. Consider the following example, a pair holding a two-dimensional index. Usually, we would make these values more accessible by assigning them to variables with a clear name. Structured bindings allow us to shorten this code to the following. We start with auto, along with any const or reference qualifiers, followed by our variable names between square brackets, and then finally we assign some piece of data. Note that the use of the auto keyword is a requirement. For example, we can't use an int here, despite all variables being integers. Now that we know how to use them, let's take a look at when we would use them. The main use case for structured bindings is multiple return values from a function. Let's consider this float2 struct that represents a two-dimensional vector. The magnitude calculates the magnitude, and the normalized function returns the normalized version of this vector. Since calculating the normal involves calculating the magnitude, a potential optimization could be to return this value as well, since we already calculated it anyway. For now, we'll use a pair to do so. Since a pair is considered a tuple-like, we can interpret the result of the normalized function using structured bindings like so. In C++20, it's possible to use these structured bindings on structs as well. This would allow us to make a normalized result struct containing the normalized vector and the magnitude of the original vector. This makes our code more readable while keeping support for structured bindings. Another great use case for structured bindings is interacting with standard library data that uses pairs. Consider this for loop. It loops through a map representing cities and their population. To use these values, we create variables for the name and population and proceed to perform some logic using these values. Structured bindings allow us to make this loop more readable by binding name and population in the head of the for loop. Now that we know how to use them and when they're useful, let's take a look at when you would want to avoid using structured bindings and some common pitfalls. First of all, readability might be a factor. Prior to C++20, structured bindings did not work on structs. If your project is using such a version, you might be tempted to start returning pairs or tuples where structs would make more sense. As a rule of thumb, never change the return type of a function just so it can be used with structured bindings. Choose a return type based on what is the most logical and most readable option available to you. Another possible pitfall of using structured bindings is that it is less reliable in a fast-changing codebase. Let's go back to our float2 struct. Let's say that in our normalized result struct, we now also want to include the squared magnitude. If the code using this function just uses a struct like normal, we can simply ignore this newly created value. However, if our code was using structured bindings, it is no longer correct and will have to be refactored to take this newly created value into account, even if we do not intend to use it. As a rule of thumb, good code is easy to change. Our earlier example, where we used structured bindings to iterate through a map, is a great example of this. The standard library is not likely to change how these iterators work, so structured bindings make a lot of sense here. All code and tests can be found in the GitHub repo in the description. Consider subscribing for more content like this. Thanks for watching and see you in the next one.